The increased development of North Queensland and tourism facilities within the region has led to a steadily increasing demand for the supply of electrical energy. The North Queensland Electricity Board is one of 7 regional electricity boards covering Queensland. It covers 458,315 square kilometres from the eastern coastline to the Northern Territory border in the west, from the Gulf of Carpentaria across to Ingham in the north, and from Boulia across to Bowen in the south. There are 81,500 customers in the region, creating a system maximum demand of 237.7 megawatts and an annual consumption of 1,445.6 gigawatt hours of electricity. The majority of customers live along the eastern seaboard, with Townsville being the major centre of population. This city is the unofficial capital of North Queensland and headquarters for many organisations supplying and servicing Northern Australia. It is a major port facility and the administrative, industrial, commercial and financial hub of the North. Townsville's outstanding economic stability, protected by the diversity of its activities, is a major base for the Defence Forces, local government and education. Tourism also plays a considerable role in the viability of the region, with major resort works scheduled for both the city and nearby islands. Norqueb, in association with Balfour Beatty Mapping and Hydrographic Services, Pure Marine and Magnetic Marine, have undertaken the installation of a new 22 kV submarine cable from mainland Townsville to Magnetic Island, a distance of 12.4 kilometres. The project will take several months to complete, with the possibility of delays due to poor weather conditions. The new cable will initially be energised at 11,000 volts, being the standard distribution voltage of the region. However, the option is available in the future to energise this cable at 22,000 volts in order to double the capacity on the cable. Magnetic Island has a permanent residential population of 2,000 people, the majority of whom reside in the 4 main bays at the southern end of the island. Development in these bays is residential, with a small amount of light industrial and commercial premises. In addition to the benefits of a regular supply of electricity from the mainland, the island also receives town water and telephone services. Magnetic Island is a relaxed tourist environment, patronised by most visitors in the region. This influx of tourists further increases the demand for suitable accommodation and facilities. Currently, the island is supplied with power from 3 submarine cables with a firm capacity of 2 MVA. With this additional cable, the firm rating to the island is now increased to 7 MVA. The cable route commences at the mainland marina switching station and goes under the marina seawall, along the beach and into the water, where it will be buried out to the end of the marina entrance channel, crossing an existing telecom cable on the way. The cable was then laid across the seabed to the island and over a reef at Nellie Bay. Several permits and approvals were required from the Great Barrier Reef Marine Park Authority, National Parks and Wildlife Service, Department of Harbours and Marine, Townsville Port Authority, Department of the Environment, Fisheries, Department of the Environment, Beach Protection, Townsville City Council, Telecom, Breakwater Marina and Magnetic Keys Proprietary Limited. Since approvals and tenders have been called, a large stockpile of sand has been deposited on the intended cable route on the island foreshore. This additional sand represented an obstacle for the installation of the new cable. The job entailed firstly digging through to the original beach and then down to the required depth for the cable. The cable specified for this installation is a 3-core 150mm square copper conductor, paper insulated, lead sheathed, double brass taped and wire armoured. Alternative tenders were sought to supply the cable. However, the Olex paper lead cable was substantially cheaper than the alternatives. Cable wear joints were used to join the sections. Surveying the land ends for the proposed location of the new cable begins with precise accuracy. A plot is set and calibrated. 200 meters of the existing cable number 3 will have to be moved to enable the new number 4 cable to be laid between number 3 and the Marina channel, maintaining a clearance of 30 meters. 1,500 meters of the number 3 cable was buoyed to determine which sections needed to be moved over. The section of cable was excavated by divers using a suction dredge in zero visibility, raised, moved over and lowered to its new position. This section was then buried to a depth of 1.2 meters using a high-pressure water jet. An underwater telecom cable complicated the procedure further, as this cable had to be raised to shift number 3. The new number 4 cable will also be buried to a depth of 1.2 meters for 1,500 meters at the mainland end and 150 at the island end. The remainder of the cable rests on the seabed. A team of divers is working in shifts below in the mud, where their only sense is through touch. With a high-capacity compressor, they have constructed a large vacuum pump, which sends a plume of brackish water 4 meters into the air.
What we've got here, the project excavates at 500 metres and relocate. It will take about 8 days. Once that's done, we then start laying the new number 4 cable. Once that's laid, we have to jet in 1,400 metres nearest the shore, which will take us again probably another 10 to 15 days to finish that work. And then we start on the Nelly Bay end, which after that.
The taste of fresh sea air is a welcome relief from the compressed air of the dive helmet. The next diver is readied for his shift, and the process resumed. The divers will be involved throughout the project, marking the number 3 cable, excavating it, shifting the cable to its new site, installing, checking and locating the joints in the new cable, and jetting cable number 4 in. Meanwhile, at the Marina end of the operation, cable ducting and excavation are proceeding above the waterline. Additional ducting is being installed in the trench to obviate any need to dismantle the rock seawall in the future. At this time, CB Marine are making preparations for the floating platform to be used by the cable jointers. The dumb barge is fitted to suit this particular job with heavy winches and 4-point anchoring capabilities. 2 of these sections will be bolted together and an air-conditioned aluminium shelter erected on the platform. Preparations are now complete for laying the new cable. A heavy vehicle barge, the Mark I, is employed to transport the cable to the site, and winching from the barge to the mainland end begins. It's a perfect day, and weather conditions are more than favourable for this process. To ensure the cable is placed correctly, the barge is anchored at the bow by 2 anchors, and the MV Tangaroa is kept standing off to keep the barge from drifting sideways during the winching. Additionally, the surveyors have located several bearing-fixing beacons at strategic positions, further ensuring the accuracy of the laying. This section of the installation is the most complex and involves floating the first section of cable into position before lowering it down. The operation is continued successfully throughout the morning and progresses according to schedule. Having winched the cable through the conduit, the trench is then backfilled to the substation. Laying the cable is continuing aboard the Mark I. The laying barge is kept on course via visual means, with a land-based surveyor calling out corrections to course via radio link. The shipboard surveyor confirms position by means of a laser distance measuring device, calculating range to 2 fixed mainland stations. This range information will then form the basis of the as-installed plot. Maximum deviation to course of 10 meters was achieved almost 100% of the time. The cable will be laid in 13 900-metre lengths and 1 250-metre length at sea, with the entire laying operation being performed in 4 separate operations of approximately 5 hours. The end of each cable is lashed to the next section as the cable enters the water. The weight of the cable and manoeuvrability at sea leads to some problems for the crew on the Mark I. Having Having laid the sections of cable in place, the dumb barge is manoeuvred into position over the first joint position, and jointing begins. Again, the services of the MV Tangaroa are called upon to manoeuvre the dumb barge into position. Cable ends are winched into the workstation, and work begins, jointing the cable.
What we've got, we've got two ends of the cable. So to join them together, so we put ferrules, right, but have ferrules in. Ferrules in the middle. We sweat the ferrules, clean them, close them up, and then we insulate them. Bring the insulation up to the size they require on the drawing, then we put the screening over. Bind the screenings together at both ends of the cables. And then after that, we slide the lead sleeve in, over, and we wipe the two ends. And we bring the bronze foil up to the wipes and re-wipe again at both ends. And then we put this sleeving up with oil, and it goes cold, and we top it up again, and then we seal the sleeving. The joint is complete. And then we put the protection box on. I don't know how you're going to explain this, but the box, we got 4 bolts come through here. When we tighten up, this pulls together, and that's the seal. And then we pull the box over the top and join the two ends, and then we fill this box up with compound.
Once the joint is sealed, the cable is ready to be lowered the following morning, a process that takes considerable manpower to manoeuvre the cable into position. The weather conditions have deteriorated since the previous day, making the operation more difficult for all concerned. The 4 anchors are then winched in, and Tangaroa tows the barge to the next joint position. At this point, the divers move in to check the joint has bedded down correctly, a process that will take place 13 times at sea and 1 on land, taking only 3 weeks to complete. This last section of the cable has come across by barge and will be installed from the semi-trailer using the excavator to start the cable pull. As with most operations of similar nature, there's bound to be some minor problems, and the excavator uncovers a small water main at the esplanade. This problem is soon rectified by local council staff who have been standing by. The remainder of the cable has been floated into the Nelly Bay site. Excavation down to the beach site continues throughout the morning.
Okay, this is where we're at with the cable now. We floated this one in yesterday. That's the last bit of submarine cable installed. We've got this one section we're excavating up here now. We'll put that in this afternoon, and that's the total cable installed. Then we've got 2 submarine joints to complete, 12 and 13. And then we've got 1 land joint here, and termination and switchgear. So we're just about on top of it this day.
Installation complete. The cable is ready for testing at the mainland substation. The cable is tested at 22,000 volts in accordance with the specification before termination on the 11,000 volt switchgear. Then the completed circuit, including terminations, will be retested at 11,000 volt specifications. Having met the test requirements, the cable is now ready to be put into service. Switchgear is activated and operational. Meanwhile, life on the island goes on as usual, oblivious to the installation and certainly better served as a result of its existence. This has been a presentation by the North Queensland Electricity Board.